3K, IE to be, what was it, 1 milliamp. Right. So if RE, look here now. If RE is 3K, and if the current through is 1 milliamp, would you say this voltage at the emitter is 3 volt? V equal IR. So there is a 3 volt here, and therefore this voltage is going to be 3.7 volt. See, that is what I can find out. If there is 3 volt at the emitter, 3.7 volt is at the base. And now I can write that relationship. I can write the good relationship of, come on.
It wouldn't matter that it was 3.6, right? Because
Exactly, you're right. Absolutely, yeah. 3.6, 3.7 is fine. Yeah. But don't forget that the for this transistor, the data sheet will tell you, right? So there's no problem, right? So VE is 3 volt. VB is 3 point, let's call it 3.6 volt for the sake of, was it Flipper? Yeah. Was it?
yeah, it was me.
Okay, right. Okay, so now we can say, okay, look at here. There are, this was R2, this was R1, this was 3.6 volt, and that was 15 volt. Can we say 3.6 is equal 15 times R1 divided by R1 plus R2? Now 15 divided by 3.6, 15,
Professor, I got a quick question too.
Yeah.
Under the data sheet, that would be VB set, like set, right? It's the saturated.
Yeah, no, it would be, no. It would be, I don't know if datasheet will give you that, to be honest.
Because the VBE set is very conveniently 0.6 is why.
Yeah, so that is correct. Yeah. So they call it SAT, VBE SAT.
Yeah, for when it's saturated, I suppose.
I don't know that. I mean, there is no saturation. That's the voltage between. Yeah, okay, but the 6.6 makes sense, but I don't know if I like the saturation.
Yeah, they refer to it as base emitter saturation voltage.
Right.
Dr. Kasai, for
Yeah.
your voltage right there, shouldn't it be 12, what we originally started with?
Oh, I'm sorry. Was it 12? I'm sorry. Yes, sorry.
Yeah, no problem.
Yeah. Okay. So 12, and that is 12. Okay. So now, yeah, 3.6 volt is equal 12 times R1 divided by R1 plus R2. And therefore, from here, R1 divided by R1 plus R2 is equal 3.6 divided by 12.
0.3.
0.3. Thank you. Right. So that is one relationship. R1. Yeah.
I was going to say, yeah, 0.3, because it looks like you put
Oh,
0.
sorry. Yeah. Okay, sorry. Yeah, thank you. That is important. Otherwise, we wouldn't get it right. 0.3. In fact, we can say 0.3 R1 plus 0.3 R2 is equal R1, or 0.3 R2 is 0.7 R1, or from here we can say R2 is 7 over 3 R1. How about that? That's one relationship between R1 and R2. And again, we will have R1, R2 divide by R1 plus R2 must be much bigger than 1 plus beta RE. That is R1, R2, R1 plus R2, which is much bigger than that. That means 200 times 3K, which is 600K. So we can say 60K. If it's going to be, oh, smaller, I'm sorry, smaller, much smaller. If it needs to be much smaller than 600K, that means it's good enough to assume it's 60K. So again, here we can say, from there we can say R1. And then for R2, we just put 7 over 3 R1 divide by R1 plus 7 over 3 R2 equals 60K. Let's just take a common denominator elsewhere. The top would be 3, that is 3 R1, that's 10 R1. Bottom is 3. Is that right? 3. Oh, that's R1 plus, that's 8. 8 R1. Am I right? That's not right, is it? Oh,
7/3 R1 squared, right? Over.
oh, that is squared. Yes, you're right. Sorry. So that is 7 over 3 R1 R1. Then here is 3, and that is 8. This is also R1. 3, that means 3 R1 plus, that is 3.
10/3.
10 third, yeah, 10 R1. So this 3 and this 3 cancels, R1 and R1 can. So we have 7 over 10 R1, 0.7 R1. In fact, we can substitute for that one. R2 would be 7 over 3 times 7 over 10. I'm totally lost. I don't know what I'm doing. Oh, no. I can say say, I'm substituting, oh, Jesus.
I think we should just solve for R1 first.
That's right. Well, I don't know. I'd say R1 is obviously 7. That would R1 to be 10K or 100K, and R2, okay, that's 300K, and that would be 700K. I don't know. You can obviously work that out. So we have two relationships. We found out R1 and R2 based on this relationship, and also R1, R2 based on this. So we have two ways. Honestly, I think I've had enough. I can't honestly calculate what is R1 and R2. I'm just saying that it's just simple multiplying and whatever. So if these are the values of R1 and R2, then that would be the values of R1 and R2. I'm sorry, just really hanging.
I'm sure we could reduce it, but I think we get 200K and then the other's 85K.
That would be great. Thank you very much, Israel. Yes, that would. So what is it? Please let me know. Okay. So
R1's 85K, and then R2.
Thank you.
R2 is 200K.
Fantastic, fantastic. Now these would be the great values. Thank you. Actually, that makes sense. Makes sense in every way. So the values of R1 and R2. Now, we want to decide on the value of, so now you can see RE, RC, R1 and R2 is decided on. So we just need to go over the three capacitors. We've been too long. It's 2 hours and 17 minutes. Do you mind if we just do that tomorrow at 1 o'clock?
Yeah.
Because honestly, I'm hanging. You must be hanging. I mean, it's just all right. So when we come back, this is the only thing left in this kind of circuit is to decide upon values of C1, C2, and CE. That's all. And then the amplifier is designed and done with. Then we can go to op-amp. Hopefully tomorrow, if we spend 2 hours, we should cover everything.
A quick question. So C in and C out are supposed to be the same values, right?
C in and C out are very much similar, yes. C in and C out are, because the same signal goes from here to there. Yes, of course, those two must be the same. CE is not. CE is not the same as those two. But yeah. I want to really want to go over these. That's why I don't want to do it now, because we're all tired. I want to give you this solid explanation why, what should be the values of these capacitors. You can, of course, refer to the lectures before, but I will do it differently, different values and different. Anyway, so tomorrow we're meeting at 1 o'clock. And then Wednesday, we are going to meet again at 10 o'clock as normal with 5 presentations. And if we cannot finish the review of this course tomorrow, then we do the rest Wednesday afternoon. So we can, at least we can say the full course was fully reviewed in some detail. Thank you very much for being patient. Thank you very much for allowing me to break down, to hang. I seriously couldn't calculate values of R1 and R2. Thank you, Israel, for coming to my help. Right, guys, thank you. Any questions, any comments?
No, not at the moment. I'm mainly waiting on the capacitor to do the capacitors. Like, that was my main issue, especially with the transistor. So
I'm sorry, yes, I promise you I will go in full some detail.
So quick question. So for the what's it called, that for this circuit, since it's the same circuit as before, the ideal capacitor would start off at a impedance of 300. Well, yeah, 300 ohms.
You see, there is, yeah, thank you for bringing this up. The reason we go for 300 ohms impedance, you know, the coaxial cables are nominally 50 ohm impedance. The coaxial cables are often, well, in fact, you can measure the impedance of coaxial cables to be 50 ohm, but then dual cables for connecting microphones, the impedance of those are 300 ohms. Those, I mean, unfortunately, fortunately, there are no older people amongst us to remember the 300 ohm cables. You know, those old antenna cables were also 300 ohms. Though, so the of course we can not that we're not just guessing, because to show you how the input impedance to the very end, based on the equivalent circuit of an amplifier, that impedance will end up to be 300 ohm, to be seen by the input capacitor. So I simplified it for you, and I said, trust me, you can always go assume input impedance 300 ohm. But if you remember, we measured the input impedance of the amplifier, all of us, everybody measured around 880 and around 8K. But the 8K was the input impedance of the amplifier. But for this signal to be seen to the amplifier, it will go through to the very end, to the load, by using the equivalent circuit of this amplifier, which we're really not interested to make it that complicated. You can just take my word for it. The impedance that the input capacitor will see is 300 ohms.
Thank you for answering the question.
You're most welcome. Right, guys, so see you tomorrow at 1 o'clock, and thank you very much for being patient.
All right, see you tomorrow. Have a good day.
Thank you very much. Same to you.
See you tomorrow, Professor. Have a good day.